All right. I am sorry, everyone, for whatever those technical difficulties were. When I shut the computer, or I should say Zoom down, an update came up, so I don't know if it was a matter of I need to update something or I just need to shut my computer off and start it again, because of course that's always the answer. But I did want to at least answer these two questions, and I will check my email to see if there are any more. Please chat off to the side if you have any more questions. This was the first question that I got. And because of our equal sign, we're going to go ahead and get rid of all of the fractions. Our common denominator will be, because this is just 9 over 1, one of each of these, which is x, and then x plus 2. Again, our common denominator is to make sure that we have one of everything so that we can eventually cancel. And when I do distribute, the x's will cancel in this first fraction, but we are going to be left with the x plus 2 that will multiply with 15. In the next fraction, the x plus 2's are going to cancel, but I'm still left with x. So we're going to end up multiplying that 9x minus 7 times x. And in this last one, there was nothing that's going to cancel. So we end up with 9 times x plus 2. So in this case, what we're looking at is, again, what looks like a possible quadratic. So I'm going to distribute through here, and we end up with 15x plus 30 plus 9x squared minus 7x. And then over here, 9x times x is 9x squared. 9x times 2 is 18x. So when I simplify my 15 minus 7, this side leaves me with 9x squared plus 8x plus 30. And over here is our 9x squared plus 18x. Now, what's nice about this is the 9x squares are going to cancel. When I subtract from both sides, those 9x squares will cancel, so I don't even have to now worry about it being a quadratic. At this point, I'm going to stop. What I am going to tell you is you will find what x equals, but don't forget to also include what x can't equal. And if you're unsure what x can't equal, make sure that you remember that it's the denominator can't equal 0. So if you want to know when it's going to equal 0, take your denominators and set it equal to 0 to solve. Whatever you find out what x is, that's what you know it can't be, because it'll make the denominator 0. So make sure that you include not only the answer, but the restrictions on the domain as what x can't be. And again, if for some reason what you come up with here ends up matching anything that's over here, you can't have an answer. That's not allowed. So then in that case, it would be a no solution. However, if it doesn't show up here, then you know here's your solution and here's the restrictions. All right, and I will again upload at least this part. I feel like this is a question on our I feel like this is a question on our written paper, so I want to make sure that I don't go, too far, so please make sure you take a look at that. All right. So on that one, that was the first question that was asked. Here was the second question that was asked, and it was a no-re question. And it had something to do with the populations of one city and the population of another city. And the way the question was asked, it said, come up with a, and I'll read it as I sit here. Apparently I can't find it. Oh. I do believe, though, it said that it was come up with an equation that was describing the combined city. So I want to make sure that we understand that when it talks about in terms of X, we're not actually trying to solve. What we're trying to do is just create a combined expression, and that way we know what we're actually talking about. So with that being said, what we're going to do is just look how to add these two together. I couldn't find the question for some reason. I thought I answered it, but it's nowhere in even my sent file. So we're going to take this 2,500 plus X, and in the denominator, I'm going to factor this right away. That way what I'm looking at is each individual factor, so I know when I look for a common denominator that I do have everything I'm supposed to. And in this case, I need one of everything everywhere. So this equation already has, because my LCM is the x plus 2, the x plus 3, and the x plus 8. There's nothing in common anywhere, so we need one of each of them. So in this one, I'm going to have to multiply by an x plus 8, top and bottom, so that I get all three of them. And then in this one, I'm going to have to multiply by both in order to get all three of them to appear. So the good thing is again, if I write this out, I only have to write the denominator now once, because we know when we get a common denominator, all of it is over the same denominator. In the top, I'm going to have 2,500 plus X times X plus 8. Over here, I'm going to have the 1,500 times this X plus 2, X plus 3. I need to remember that this x plus 2 and this x plus 3, I factored it to make sure I had the right LCM, but it really was x squared plus 5x plus 6. That's what we had here when we factored it here. So to make my distribution a little bit easier, I'm going to put it back in that x plus, or excuse me, the x squared plus 5x plus 6. So when I distribute, I have in the top here 2,500 x plus x squared, 2,500 times 8, which is going to be plus 20,000, and then 8 times x is 8x. In this next one, I'm going to have plus 1,500 x squared. 1,500 times 5 should be 45, or excuse me, 7,500. So we end up with 7,500x. and then 1,500 times 6 would give us 9,000. And that's all over our common denominator of x plus 2, x plus 3, x plus 8. So now we're going to combine like terms. And in combining like terms, we end up with 1501 as our x squared term. 2,500 plus 8 plus 7,500, 10,000, 8x, and then 20,000, that was a 9,000. So 20,000 and 9,000 give us 2,900. And that's all over x plus 2, x plus 3, x plus 8. Now, I can't say, because I've not tried this problem in particular in NORI, but if this doesn't work, it's quite possible you need to multiply out the denominator. I'm finding that at least in the geometry, no matter how many times I say do the exact value, we have people putting in decimal answers where fractions and radicals are required. So if this is the case, you have to remember that this is just like multiplying anything. You always multiply 2 at a time. So even if this was something like 2 times 3 times 8, we would do 2 times 3 first, get 6, and then take 6 times 8 to get 48. So, oh, I just saw Ren, thank you. I did fix that, thank you. Make sure here, if we put that answer in and as it's factored doesn't work, x squared plus 3x plus 2x plus 6. So we know that that first one is the x squared plus 5x plus 6. And then we have to multiply in our x plus 8. So x times x squared would give us x cubed plus 5x squared plus 6x. And then we do the 8, so plus 8x squared plus 40x plus 48. And so it could be that our denominator is written as x cubed plus 13x squared plus 46x plus 48. And this is it multiplied all the way out. So it could be this, or I am hell-bent on not adding that last 0 for whatever reason. And then over x cubed plus 13x squared plus 46x plus 48. So it just depends on how everything is plugged in. So hopefully that helps answer that question, just because it does combine quite a few concepts. But there is no solving for anything in this particular question. It was just asking us to create the function to know how what the population is after X years. So X is going to stay in the problem. Were there any other questions that you would like for me to go over? I'm going to check my email one last time to see if there's anything. Okay, I don't have any new emails. Is there anything else that you would like for me to talk about before we sign off for today? Number 9 on the written word or the paper, Hallie. Okay, let me pull that up. Make sure I have that. All right, does that look like the problem you want to talk about? All right, and then it sounds like number 15 will do something like this. All right, so same question, a little different, so I'm not just handing over the answer. So does that look like what you're talking about, Molly? All right, so I am going to start with number 9. And because we're just going to simplify this, I just need to figure out what my common denominator is. So the first thing I'm going to do is I'm going to factor this. This is the difference of 2 squares. So this is going to factor into 3 over w minus 3 minus 2 over w minus 3 and w plus 3. So I need to make sure that everything has the common denominator. Well, right now, this guy has both, but this one only has w minus 3, which means in order for this to work, I have to multiply the bottom by w plus 3, and I have to then multiply the top by w plus 3 so the fraction doesn't change. That means this second one will just stay minus 2, but the first one I'm going to have to, as my denominator stays the same. The top one I'm going to end up taking 3 times that w plus 3 and subtracting 2. The only thing you need to do is simplify the numerator. I'm going to stop there. So make sure you simplify the denominator and your answer will be whatever is left. Make sure you check to see if for some reason there's something that can be factored, which it's doubtful, but just make sure that you're looking for the numerator to be simplified. So with the bottom question, now I made this up, so goodness knows what the final answer might be. But it does say that Mary can wash her dad's truck in 2 hours. Molly can wash the truck in 1 hour. If they work together, how long would it take them? So again, this problem is just a build of fractions. So we know that one job is going to take 2 hours, one job is going to take 1 hour, and then we want to know what it's going to be if they worked together. So being very careful with this, we know that we set this up as 1 over the total time that one person has. We're going to add one job over the total time of the other person, which ends up being 1 over 1. And we want, because everything's in terms of hours, so it kind of makes sense, one job in 2 hours, one job in 1 hour. And then we want to know how long would it take them together. Well, we don't know that one job in however many hours. So, no worries. You're good, Molly. There's such a delay this way. I don't know why, again, the Zoom session worked for a couple people, but not for everyone. So I'm going to have to see if it's just a matter of me updating or shutting down over the weekend, and hopefully it'll all be good. But after break. So again, one job in the 2 hours, one job in the 1 hour. How much is that one job going to be in however many hours it takes when we combine their efforts? So I need to look at this as I could do a common denominator and set them equal to each other and solve, or I could just get rid of the fractions altogether. A 2, a 1, and an x means that my common denominator is going to be the 1 times 2 times x, or just 2x, because 1 times anything is itself. And when I distribute, the 2's are going to cancel, but I'm left with x. The 1's, all right, who cares about that, is going to end up staying 2x. And then over here, what ends up happening is my x's cancel and I'm left with 2. So we end up with 3x equals 2. And when I divide by 3, we end up with 2/3. Now, 2/3 of an hour, there's 60 minutes in an hour. So 2/3, keep that in mind, is going to be, anybody? What's 2/3 of an hour? Because I highly doubt anybody in the real world will say it takes 2/3 of an hour to wash the car, but they may say it takes so many minutes. So does anybody know how many minutes 2/3 of an hour is? Good, 40 minutes. So if you're unsure of how we got that 40, just remember that there's 60 minutes in an hour. So all we're going to do is take that 60 times 2/3 and we end up with 40 minutes. And that was actually a pretty good example because if you're curious, that may be the case when you're doing number 15 on your paper. All right, any other questions? Well, if there are no other questions, I'm going to check my email one last time just to make sure. And I received nothing new. So email me your questions. I will send you back, in most cases, either an explanation or documents that look very much like this. If for some reason, too, you guys are having any trouble with anything and there's a group of you that want to still meet with me over spring break, just let me know. I'm going nowhere, and if I'm free, I will let you know when we could, and we can do whatever. So otherwise, I will talk to you guys after spring break. Please enjoy yourselves, do something safe, and we'll go from there. So I will talk to you after spring break.